Welcome to this roundtable meeting, which will look at electrifying agricultural machines, the quiet revolution. As a kind introduction noted, my name is Julian Buckley, and I'll be the moderator for the session. I'm the editor of Diesel Progress International magazine. There it is right there, the latest issue. If you know about Diesel Progress, and DPI, that's great. Thank you very much for following us. If not, you can go to dieselprogress.com and check out our news coverage and sign up for our print magazines or our newsletters. We have lots of newsletters, and we're even starting a daily power newsletter in the new year, which I think it's almost unique in the market, so that'll be worth checking out. So please take a look, or you can even come and visit us down in Hall 15, stand H18. That's H18 for those of you who are taking notes. In DPI, we cover a lot of the latest innovations across the power market, including the agricultural sector. But it's noticeably changing in the sense where you see more electrification coming in. And it's not only, a year ago, 2 years ago, you would see tractors, the diesel engine would be getting ripped out, and then a battery pack would be slid in, and there you go, an electric tractor. But it's even progressing beyond that now, to the point where peripheral functions are getting electrified as well and taking the power from the battery pack, and you get a full solution. And then that drives so many things. It drives sustainability, functionality. You get the data that's coming off these machines that simply basic hydraulics simply doesn't offer. So you get the additional control and all the related benefits. So think with that in mind. Today we have with us some industry executives, and they will explain the tech behind their own electrified products. And also, we will hope they will give us some thoughts as to where they see the industry and the market going in the future. So, the roundtable will be just basically a Q&A, me firing some questions at these guys, and I hope they're prepared for that. But towards the end, we'll open up the floor, and if you have any questions, please just raise your hand, and I'm sure they'll be happy to respond. Speaking about our panel, today we have with us, well, actually, we have 3 out of the 4 guys with us. The one guy that we're missing is Bas Verkuyken. He's founder of the CEO of Elio Technologies. You might know Elio. They were picked up by Yanmar last year, and so they're developing electrified technologies for Yanmar. But with us, more importantly, the guys who are with us, we have David Stockbauer-Muir, and he's head of electric systems development off-highway for the ZF group. David, you want to come on up? There he is. And the third member of our panel is Mark Schwager, and he's president and co-founder of Monarch Tractor. Mark, you want to come on up? Come on, there. And our 4th panel member is Kari Aaltonen, who is Director of Engineering at Agco Power. Please join us. Oh, Bas is here.
Yeah.
When suddenly we are 4. We have our 4 musketeers. Come and join us. Okay. Just a brief introduction for each of these guys. So Bas, as I said, he's with Elio, and Elio is a battery technology developer that's based in the Netherlands. And they deliver battery systems for a wide variety of industrial applications. And as I said, in 2022, they were picked up by Yanmar, and so are now coordinating with Yanmar to electrify a lot of new equipment and machinery. David at ZF He's been with the company for 12 years, and over which time he's held several positions in development, project, and product management. Mark, at Monarch, he's got 15 years of experience leading manufacturing organizations, many of which are related to Tesla, which obviously massively electrified stuff. He even collaborated with Toyota and was part of the team that brought the RAV4 EV, if anybody recalls that. It was about 10 years ago that came out? 12 years ago. 12 years ago. Okay, and Carrie from AGCO, he's been with the company for 26 years, overseeing global engine and power unit design operations for agricultural machinery. And they work with Fendt, Massey Ferguson, Valtra, and Gleaner. So, gentlemen, welcome to the stage. One more time, a round of applause, please. Thank you. Okay. Moving swiftly on, let's get this party started. Okay, Mark, my first question is for you. And Monarch has recently demonstrated, it's the MK5?
Mark 5.
Yeah, the Mark 5. All-electric tractor in Italy, and now it's here at Agritechnica. Yeah, can you tell us what were the driving motivations behind the decision to develop this new model?
Yeah, so from our side, we look at farming a little bit differently. We look at it in terms of how do we alter the economic pain points that farmers have when operating their equipment on a day in and day out basis, especially for high value crops. So what are the primary economic drivers? They are fuel and labor. And so if we can address these economic pain points effectively by having a lower cost fueling option in the form of electrification, as well as automation solutions, we can fundamentally adjust farmers' economics such that they're free to adopt any practice. So rather than being locked in by today's farming practices, if you alleviate the economics by introducing these technologies, we can introduce biodynamic processes, organic processes, and they become not just economically compelling, but economically superior. And that is the fundamental motivation. In order to do that, we had to make sure that there was no compromise with respect to how the tractor is operated. So we wanted to make sure that we worked with the existing ecosystem that farmers are used to, which is the same operators, the same inputs, the same implements. So we have electronically driven by-wire controlled hydraulics, for example, so we can use all of the existing implements that farmers use today. So these are some of our motivations, but really the way that we look at it is how do we economically unlock farmers to adopt any practice? And that's why we have focused on electrification, automation, and data.
Can you give us some specifications about the powertrain that you use in the Mark V, and why that was particularly important for the model?
So for high value crops, we wanted to choose something that would have the biggest impact in choosing which size platform we wanted to make. So we went right down the middle of the market globally, which is essentially the 40 horsepower tractor, which is the highest volume produced tractor form factor in the market. Hundreds of thousands, if not millions per year. This gives us the potential for economies of scale so we could engage the automotive market for componentry. It's around a 40 horsepower tractor, but with the electric motor can peak up to 70 horsepower. It has twice the torque of a typical diesel tractor of the same size. Our battery pack allows for up to 14 hours of use. It is a 110 kilowatt hour battery pack that is fully swappable. So if you're limited by infrastructure, as many farmers will be, there won't be DC fast charging on a lot of farms. What that allows you to do is swapping a spare battery in the middle of the field in less than 10 minutes, you can go 24/7 if you need to as a farmer. At the same time, we wanted to make sure that our tractor had the autonomy in terms of the amount of time that it can operate for a full shift. So that's how we looked at the parameters for setting as much battery power as possible inside the tractor. And essentially we charge at level 2 because that's what the infrastructure supports on many farms.
It's like the Briggs and Stratton setup where you can swap out the batteries and keep working. It's but scaled up quite considerably.
Yes, it's a 700 kilogram battery pack.
Yeah, indeed. Carrie, I understand that AGCO and Fendt have been working on the H2 Agrar hydrogen fuel cell tractor. Now, I bring that up because while hydrogen clearly is not electric, what it produces is electricity. So, can you say what has changed over the standard fuel cell power unit to help it withstand the harsh conditions of the agricultural sector?
Yeah, actually, the fuel cell what we use can come from PowerCell Sweden, and they are actually quite experienced to making a heavy-duty power cells, which are used in a harsh environment. But that core fuel cell comes from PowerCell, and then we built a frame around it, a dedicated frame with the dampening to withstand the vibration and so on, so that we can meet the specs of the fuel cell, so that we don't exceed the vibration specification and so on. Then air filtration is on our side, so we need to of course take care of the dust and other particles in the air, but also the fuel cells are sensitive for like ammonia, which might be there as gas emission in slurry application as an example. So we are still working to how to protect the fuel cell against those harmful gases in the atmosphere and these kind of things. So then one challenge there is to control the power of the fuel cell, because the response time is not really good compared to battery, so that there is a balance all the time between the fuel cell and the battery. That is one challenge. And with the prototype tractor we face a problem with the filling, because the standards supports only up to 10 kilos of hydrogen, and our tank size is altogether 20 kilos. So there was one challenge. And overall, if we think about challenge of using a fuel cell in agriculture tractor where we don't have the ram air, which means that the cooling system becomes very important.
Yeah.
And if you think about the fuel cell tractor operating in like in Phoenix, Arizona, so it might be 45 Celsius degrees, and if the temperature of the system is 80, so it's only 35 Celsius degrees of temperature to the ambient air, which means that you need very powerful cooling system, because at the end of the day, the total system efficiency is run at the same level as diesel engine. And diesel engine temperature, max temperature coolant is something like 106, 108.
Yeah.
So which means that we need to have a very, very efficient cooling system. So those were just a few things to make.
Have you used, I understand from talking with Cummins, for example, they've built a system similar to a turbo, but it forces more air. Do you use something similar to try and get more power out of the fuel cell?
Yeah, sure, but that's on a research level at the moment, like the whole project. So we don't know what we will have in future, but we are working on those. I got you. Understand.
Good, thank you. Baz, turning to you.
Yeah.
Elio introduced a new energy-dense battery cell for off-highway applications at ConExpo. Can you say how that pack could be used in an agricultural situation?
Yeah, of course. So we introduced a system, so not the cell. So we do purchase the battery cells, but basically indeed utilizing the economies of scale of the automotive industry, but making it like accessible for industries like the equipment industry, also the off-highway industry like construction equipment, where you of course see quite a different kind of challenge, engineering challenge, as the automotive industry, where you have like very high volumes, all similar looking vehicles, and of course in the off-highway industry, you see it around here. A lot of different kind of machines, different kind of use cases, different kind of requirements, which also puts different kind of requirement on the battery system. And with our new generation, we're essentially making a battery platform with which we can configure the system in different voltages, different capacities, different shapes, which is of course essential to actually give a battery system to a machine that actually meets these specific requirements. And our Gen 2, comparing with our Gen 1 product, essentially uses a different kind of cell, an updated cell format, which gives it a higher energy density. I think this is specifically the volumetric energy density. I think is critical in electrifying agricultural equipment.
Gotcha.
Making sure that you can actually indeed make a full day of work possible, depending on what the farmer needs. I think that's critical for specifically the agricultural market.
Does Elio make its own pouches, or is it, or do you get those brought in? I mean, literally, do you build the battery from scratch at Elio, or do you use suppliers to bring?
Yeah, so of
that
course,
together?
for the battery cells, we use suppliers. So
Yeah.
they are indeed making use of the economies of scale that are mostly from the automotive industry. But basically, all the technology around the cells is all purpose built for this industry. So that also means having to deal with, of course, the specific requirements that are here, the specific challenges such as vibration. These kind of things are much more important to tackle with like this agricultural industry.
Absolutely.
Than the automotive.
Yeah, it's not driving down. It's not like driving down the highway.
Exactly.
Driving across the field. No.
Yeah, exactly.
Gotcha. David, looking at related components, can you give us more details about the e-Teramatic electrified CVT transmission that ZF has produced?
Well, the difference between the conventional system is we took out the hydrostatic module and put in some two electric machines. The functionality itself is the same, with the benefit that we save about 5% or we gain 5% of efficiency. And the second one is we are able with this system to transport electric energy to some electrified implements or other electrified system components on the tractor to increase the traction on the field or increase the possible work with some implement, and also make the system itself more efficient.
It's what kind of share do you think that's going to take? I mean, do you think is it going to be parasitic in taking away from other ZF transmission options that aren't electrified?
We would never start some parasitic actions. We think, or let's say, it's at the moment not easy to predict how the market will develop in the future, and we think that especially in the system with higher powers or above 300, 400 horsepower, it's not easy to build up battery electric systems. So the power density is not available. We talked about some possibilities to swap the batteries. That's one possibility. The other one is to install furthermore the combustion engine and maybe then use some eco-fuels or e-fuels to run the system itself, or some similar technologies like the H2 engine, but we think it will be a mix, and this ECVT has, from our point of view, future for sure.
Yeah, definitely, yeah. Well, Mark, turning to you. Now, I was doing a little prep for this, and I saw that the Mark V tractor had done a tour of Italy, like an introductory tour. And generally what I was looking at was a tractor that was ideal for particularly, I mean, because it's got some automated functions, yeah?
That's correct.
Some automated functionality, but it was, and the primary situations where it was being used were effectively fruit picking, vineyards and orchards. Now, do you see in the future bigger tractors being electrified to the point where they'll be plowing possibly even a combine with an electrified powertrain? Because I realize now that you've got that almost coffin corner situation where you get a smaller battery pack is more efficient because it's lighter, and as you size up, clearly you add weight, and that counteracts any power benefit. Your thoughts on that?
Your assumptions are correct.
Yeah.
Where we think the technology is applicable today is everything around under 125 horsepower. we can get the power energy weight equation correct. And you're already seeing Monarch technology in larger vehicles. Our partner and investor, CNHI, has already integrated Monarch battery technology into their T4. So we're already seeing the next step up to the next size of applicability in that battery technology. As technology continues to improve, and Buzz talked about this from the energy density side, we will see the horsepower limit start to climb. And typically what you see in battery energy density improvement is 50% every 5 years at the cell level. Of course, there are things you can do at the pack level as well to increase that efficiency, and that both on the volumetric and gravimetric side. But the cell, intracell technology is the most important thing for increasing that energy density. So we do see the opportunity to bring it into larger and larger pieces of equipment. Now, 500 horsepower, that might be a ways out. We might need a sort of an energy, rather than incremental change from the battery technology industry, we may need a fundamental shift. Perhaps that will come with solid state technologies and all of these new investments that are going into a number of different battery technologies, both on the cathode and anode side of the battery. But in general, it will be some time before the higher horsepower tractors have yet a fully electrified powertrain. But as of course I'm speaking to the market here, as many of you know, 90% of the market globally is below 100 horsepower. That means 90% of the market by a unit basis is applicable for electrification technology. So we're here to be a big part of that.
That's an interesting point. That's a very interesting point. Do you think the 50% increase in capacity, power density can be maintained, going into the future using the same chemistries that we're looking at now, or is it going to require new chemistries?
It will require innovation within the chemistry. It may require new chemistries, but I've seen this consistently over my 15-year career in electrification, where that incremental change has been very, very consistent. It's not Moore's Law, it's Moore's Law for batteries, so it's a little bit slower.
Moore's Law is actually falling apart. That's why they're.
I'm not an expert in that.
Looking at no, me neither. I don't want to claim any expertise there at all. David, with electric power in mind, ZF has stated that powertrain electrification and connectivity are mutually supportive, and I was hoping you could give us some more details on that and how you see that working.
Yeah, for sure. I think everyone in this room knows that with the electric system, it's possible to gain much more data out of a system like it's possible from the combustion engine one. And so that it's possible to use this data for some maybe predictive maintenance functions, or also some automated drives. We learned it. I think say it again, and you know it also. It's much more easier to handle the electrified system in direction to some automated drives and what else.
It's do you think electrified models offer a greater opportunity for data than an equivalent diesel model? Is that the way it's working in the sense of the way that the control mechanisms of the electrified machine are more up to date?
The point is with the electric machine, you always get the information how high the torque during the operation is, for example, also the speed, and you can get out the data how long this electric machine, for example, for the driveline is working over the operation hours. So with the diesel engine, it's not possible because the diesel engine drives the whole complete system, and when this it's only some working activities, it's not the same like driving. So out of this data, you can expect when the transmission, it's ready for some maintenance and such things.
Got you. I see what you mean. I do. Carrie, AGCO is obviously a big name in diesel engines, but now that you're getting into the electrified sphere, I mean, and I don't want to try and predict the death of diesel. But at the same time, do you think that's what's going to happen? I know, don't. Do you think? I mean, but in spending all the money in developing electrified solutions, you clearly want a return, and to get that return, you have to sell them. And when you sell an electrified solution, that's a diesel solution that's not been sold, right?
Yeah, it's true. But if you think about the Akku Power and Akku overall, so 15 years ago we had an initiative. We wanted to make battery electric vehicles, tractors and sprayers and other stuff, and we did make the prototypes. But I was leading that activity on our Akku Power side because at that time I was responsible for the electronic and software development, and I was really excited about the opportunities. But 15 years ago, I would say that the world was not ready for electrifying agriculture machinery in big scale.
Yeah.
But I think today, because of the past cars, automotive has the development has been very disruptive even.
Yeah.
So I think now there's a new opportunities as we have heard already in this discussion. But yeah, I think it's mentioned that the battery electric vehicles works very well when we speak about sub 100 horsepower range, because the fact is that the batteries are not good enough power the energy density today to power the bigger tractors. That's simply the fact. I hope that the batteries will have the energy density development. But when we go back to the diesel engine, so we just released or launched 1 year ago our latest engine family, core engine family, which you can show in our booth. So we did a lot of things to reduce the CO2 from 5 to 10%. Just with the engine technology, and now with the HVO, if it is available and farmers can use it, you can reduce the CO2 by 75 to 90%. So diesel engine is still quite good when you use the good fuel, and I hope that there will be a lot of investments in this area. We need the HVO to reduce the CO2 fast. But when we come back to the electric tractors, I think there will be some growth. We have some project inside Akko for the next generation battery electric tractors. And we are deep in that development with Akku Power with my team. So they are coming, but I think I will retire before diesel engines will be killed.
You heard it here. You heard it here. Vance, as a battery developer and manufacturer, I mean, what do you see? How do you see the market developing for electrified machines? I mean, I guess you would hope that it's going to get broader and wider and bigger. I mean, as a battery producer, that's where your bread and butter is the market getting bigger. But is it? I mean, what kind of size do you think? Can you give us any numbers? Do you think? I mean, or percentage, like volumes of how you see it growing?
Yeah, no, good question. So I indeed tend to agree with also the folks here that indeed below, let's say 100 horsepower or 80 horsepower, there's quite makes sense already. So I think also the use case makes sense, but also the also in terms of the energy density, it works well. And indeed, it's quite a big market. So that's what we see also in construction. The big market is of course in the compact machines. But of course, the impact in the end will be in the bigger machines, because of course, if you compare the pollution of a single machine in the bigger horsepower range, this of course has a big larger impact. So I think units does not necessarily equal like the impact it might have, like the pollution it might have. And I think it all comes down to the energy density when we will see like the bigger machines being electrified. And I think in the coming years also we are of course in close contact with the cell manufacturers. We do see quite some nice developments coming up, which will get us quite far above the 300 watt-hour per liter range. And I think this is also a nice tipping point when actually the somewhat bigger machines also make more sense, and it becomes actually applicable, and actually it still provides the good use for the farmers, because I think that's in the end what needs to be fixed. Like if it's not, if a farmer cannot do his job in the right way, I think it will never really catch up. So I think that is really what we will see indeed in the coming 5 years. So in our new generation, which we plan right now in 2028, I think we can go well above the tipping point, which will really see an uptake in also the bigger machines.
Cool.
Yeah.
Cool. David, looking at ZF, they operate, so far as I understand, a best choice strategy when it comes to development of electrified drivetrains. And I was hoping you could give us a little background on that.
Yeah, I can. This best choice strategy is it's more a sales strategy, so it's or a sales a tool to make it easier for our sales guys to have a look and an overview which components and systems are possible to sell in the different countries and regions. So for sure we want to cover up the whole market, it's clear. But we have to consider when we do this what's the status of technology and also the possible pricing and so on, what you can gain there. And for some example, in some regions the power shift transmission is then maybe the high line or premium line solution, and in other countries it's maybe the baseline solution. And there is more, the technology is more developed. You can use there some electrified systems also, or the market needs it. So that's the background from this best choice strategy.
I see. So in terms, it's not a good, better, best.
Yeah.
Setup.
So it's not the same for every region. So it depends on the region, it depends on the market, and it depends on the technology development status.
Absolutely. Yeah. I can see how that would work, because then all of a sudden your electrified proposition effectively becomes global at that point. Yeah. Kari, at the other end of the scale, I understand that AGCO has been working with Blue World Technologies. And that's on a range extender platform, powertrain, not platform. And that's using liquid methanol. Could you tell us more about that and how it plays into what we're talking about today?
Okay, yeah, sure. Actually, we wanted to offer something to our customers for support their electric tractor usage in the field. So because we know that in some applications like the E100, the operating time autonomy is just 4 hours per day, and we wanted to double it. And we know that while the farmer is working in the field somewhere in a remote location, there's no chance to charge the battery there. That would help, or it might be a really expensive solution. What we heard here, that swap the battery to a fresh one, and so on. So I don't think it's very feasible. That's just my opinion, sorry. My opinion. But anyway, we thought we have to support our farmers somewhere so that they can work 8 hours in the field. And this was the idea, which you're going to see in our booth. And yes, we are working with Blue World, Danish company. They are expert in this high temperature proton exchange membranes. And this one, what we have here, is around 15 kilowatts, and by using it, it uses methanol. There is a reformer which processes the methanol into the hydrogen, and the hydrogen is used in this high temperature PEM. And that produces the electricity which is fed to the tractor. So it can be used as a retrofit solution, and you can use it while you are driving. That is tested already, it works. And it's kind of a mobile battery charger which uses methanol. And we expect that the methanol production volume will increase in future because it can be produced out from the hydrogen. So it's green fuel, and especially in maritime application, we expect to see some applications there which use methanol for the same reason. We want to be sustainable and use carbon neutral fuel. So methanol is excellent for that, and because it's liquid, the logistics are exactly the same as with the diesel fuel.
Yeah.
So it's easy to carry to the end of the field or wherever you use the tractor.
Yeah, no high pressure tanks or anything
Exactly.
like that. It's just a regular.
Exactly. So it's much more easier.
Yeah.
So
And you can make methanol from methane.
Sorry?
You can make methanol from methane, and if you're collecting methane on your farm from a slurry, then you've got a virtuous circle.
yeah, could be. I'm not the expert on that area, but could be.
Neither am I. Mark, lastly, my final question. The Mark V has got a series of automated features and functions. And if I was hoping you could outline a couple of those, but also moving forward, what would you see next as being an automated feature on a tractor that you'd be looking to implement?
Great question. So just to kind of give you the sense of scale that we're at today, Monarch has delivered more than 350 units in the United States. They're in use today. they're using the automation functions. We've enabled them for our farmers to be able to use them today. So in many cases, when we talk about technologies, it is one thing to develop, it's another thing to industrialize, commercialize, distribute, support. These are real things, real challenges that companies need to be able to overcome once these technologies get out of the lab. That's where Monarch is today. We are developing scale, support at scale. And so allowing the farmers to use these functions, use their tractors like they do any other tractor. So when you think about what does a tractor do, the tractor does weeding, it does mowing, it does spraying, it does hauling, disking. All of these functions are things that we've thought about putting into the tractor and enabled it to do. We've done the testing, we've done the development, and we've commercialized these functions to be able to be done by farmers. So farmers can train the tractor by driving it. We labeled the tractor as driver optional. They can also drive the perimeter, map the field, and then go say, mow block A. And it will do that, and you can choose every other row, every 3 rows, and it can do those sorts of things. So from an automation perspective, we've given the control to the farmer to be able to choose how they want to operate that tractor, and they can drive it if they want to. I think the big difference is when we look at what features are yet to come, it's really not a difference in features. It's just more applications, more sensing, more insight from data that we can provide while the autonomy already works and is in use today. I think that's the big difference, is how can we make the data that the tractor collects while it's going around without cost for fuel, without cost for labor, adding value to the farm, and collecting data, providing insights to farmers.
Yeah.
That's the next step on how not only we can add value using the automation, which is probably the most immediate value. How do we have year-over-year insights? How do we have actionable insights from the moment that the data is collected, where the farmer not only can understand what the tractor has perceived, but can give direction to the tractor to go perform.
Yeah.
That's the difference.
And that's and a system that can almost self-analyze its own data, so you get actionable information rather than the poor farmer sitting there paging through reams of data, so trying to figure out what's going on.
They'll shoot you if you do that.
I don't. Ladies and gentlemen, let's open up the floor. Do you have a question for our panel? Yes, sir.
700 or 400 volt infrastructure for everybody. So we are arguing about the automotive industry and the truck industry. So what are going to be used in the future? Which is the future?
I can answer from Akko side, so 700 volt is our
There you go.
Yeah,
700.
tractors.
400 automotive is what we are looking to tap into. Remember that the 700 volt systems for high-speed charging will destroy the battery.
Okay.
I know.
Oh dear. We've got some conflict going on. We're fine with both. He's an agnostic battery man. Anything goes. Anything goes.
I have a question too, if possible.
Sure.
You're always taking the perspective of the machinery. You're always sitting on your electrified tractor and talk about power and on possibilities to drive it and horsepower and so on. But nobody talks about the electric grid. You always say we sell electric tractors, but we can't power them on. The stronger the battery, the longer it takes to put electrified energy in it, and it's very expensive. So how do you cope with these problems in the growing market?
May I?
Yeah, of course.
So Monarch did not choose to integrate DC fast charging on its tractor. Why? There's no superchargers on farms. It doesn't exist. What does exist on farms and in barns is a 220 volt plug used for welding. That's the available infrastructure today. So why should we do more than level 2 charging if the market doesn't support it? That's why we developed a swappable battery. 220-volt architecture at 22 kilowatt in Europe means that we have a 5-hour charge time. That doesn't really work if you have to go 24/7. That's why we have a swappable battery. So we work with the available infrastructure, and that's how we've designed our system, and we've also enabled the 24/7 operation.
Yeah, maybe I can also give some comment on this. Out of our experience from the construction machinery market, we learned that especially the compact equipment, and I think it's also the direction into the small farm tractors, they mainly use the overnight charging. So they use the vehicle over the day, and the battery charging, or the battery is able to cover up the whole operation over this day, and then they use the overnight charging with low
That
energy.
doesn't work. That does just work for the smaller tractors.
Yeah.
But we were talking about scaling up until harvesters. The future of electric-driven vehicles, and there you need, I guess, thousands of kWh. So and we don't have the grid for it, and that's the problem. And I guess it's a problem for the farmers. So the countries have to cope with your power of innovation. It doesn't. That's the bottleneck, I guess.
But it's a chicken and an egg situation, though.
Yeah,
really.
of course.
I mean, because it's up to a government. If a government wants to implement a green strategy, then they're the ones that are going to have to back, with some investment, the grid upgrades that are going to be necessary to deliver the power for these electrified machines and the mega harvesters that are going to be carrying around 5-6 tons of batteries. But
Do me a favor, next time invite the representatives of the Ministry of Energy and Economics to this roundtable. That would be nice.
May I answer also? So, for this reason, we have developed this microgrid concept, and we are working on it. And we have a couple of pilots, and that's exactly the reason why we are developing it. So, because there might be windmills, there might be solar panels, generating a diesel generator, batteries. So, to connect all of those energy sources and also the energy consumers, including the tractor. So that's exactly the reason we want to support our farmers. We are not yet there where we have to be in future, but we are working on it.
I think we've got time for a couple more questions. Anybody? Yes, please.
We've talked a lot about electrification. You guys are doing some really good work. It seems like it's a lot of hassle for the farmers to change their infrastructure, to work with shorter time frames. Like, what is the benefit for the farmers in buying electrical machinery?
The question was, what was the benefit for the farmers to electrify their vehicles?
So for us, it's economics, but we know that electrification is not a strong enough value proposition by itself for the farmers. It's not. That's why electrification and automation is required. We must address both economic pain points in order for the benefit to be there. Now, we've done everything we possibly can to lower that barrier to adoption. No additional infrastructure required, for example. Plug it into your 220-volt plug that's already there, use it as a tractor, use your hydraulic implements, use it with your existing drivers. It's easier to learn than a traditional tractor to learn how to drive because of all of the electronic controlled guardrails that we have. So these are the important things about lowering the barriers to adoption. We don't want to have to make these enormous investments because then the farmers will say no. At the same time, we do work with the governments, as we have with the state of California, now with the state of Washington, with the US government, to ensure that the farmers have the right incentives available to them to adopt the technology, not just at price parity, but at a lower cost than diesel. That's the way that the state of California is now supporting us now. And it is a little bit of the chicken and an egg syndrome, where prior to the tractor being essentially being in existence and it being commercialized and available for farmers with distribution and service, they were unwilling to put this incentive into place. Only by actually getting to market, actually bringing it to farmers, and actually demonstrating that it works and provides the value proposition that we advertise, can we get those incentives.
You had a question?
Yes, I also have a question. I heard the sustainability word pop here and there, but I realized that most of the time is always talked about CO2 neutrality. and I was asking myself if you also consider like aspects like recycling batteries, or also the extraction from lithium is also problematic, and how you manage that.
Yeah, no, good question. I think it's very important, of course, this topic of recycling. So I think that's also, at least for us, it's a big thing. And of course, besides recycling, there are also possibilities to maybe give a second life to battery systems. So that's also something we're now actively working on, and also designing our battery system as such that it is easier to like extract the materials out of it, so that they can be reused for some recycling purposes. And I think also, and this is I think a good thing also from government perspective, that they're also now stimulating more regulation, which also enforces battery manufacturers to engage in certain recycling activities, and having some sort of passports. So that's something which is now also being introduced, the battery passports, which also enforces you to give a very good overview of what kind of materials are inside of your battery system, what is the ecological footprint of all the materials, thereby also stimulating actually that you are reusing the materials, because that gives you a better, let's say, passport. And I think these kind of things are necessary also to stimulate that they're being, these kind of sustainability practices are adopted better. Yeah.
And you know that in the States, they've implemented a regulation now to promote recycling of batteries where there was virtually nothing before, to where if a battery, even if it's brought into the US from China, for example, if it's recycled in the US, it's considered US material. And they get a higher rate of return on that as well.
IRA credits.
There we go. There we go.
Yeah.
Okay, I think we're just about out of time, but I would like to offer a final thanks to my panelists today. We had Bas Verkijk, David Stockbauer-Muir, Mark Schwager, and Carrie Aaltonen. Ladies and gentlemen, please, one last final hand. Checking us out. Please come down if you want to find out more about Diesel Progress or Diesel Progress International. We'll be covering all this and more moving forward. Oh yeah, I should say, by the way, in January, it won't be Diesel Progress anymore. It'll be Power Progress and Power Progress International, because of electrification and other fuels coming onto the market. This is what the change that is being brought upon us. So, my name is Julian Buckley. Thank you very much for joining us. Enjoy the rest of Agritechnica. Thank you.